Hi, everyone. Welcome to IR202 Research Methods 2. So we are by now on week 11, and we have covered so much. I am doing this recording because I received some feedback from the class asking for more recorded material to help you with the final exam. And many of you suggested that it would be a good idea to have a recorded lecture at hand so that you can return back to this as frequently as possible. I'm going to go a little bit fast compared to our class exercises because, again, you can just stop this, rewind, rewatch as many times as possible. So it's going to go a little bit fast so that I can deliver as many material as I have to. So before we start, I'm going to do a recap of what we did on week 10, the FAO data analysis, and especially the whole issue about pivot tables. And remember that our founding or foundational question was, what are the correlates of hunger and undernourishment in the world? A big international relations question. And in order to address hunger and undernourishment, we have to first deal with data related to that. And the data comes from the Food and Agriculture Organization of the United Nations, or FAO. And the website is fao.org. And then you land on this landing page. And then in the statistics part, there is the FAO stats. From here on out, I'm going to just call it FAO stats because it's just easier to pronounce. So we have to go to FAO stat. And in previous lectures, we discussed how to pull data from World Development Indicators, UN Human Development Index, and it's useful basically to be familiar with as many different data sets as possible and data interfaces as possible. So for that, this week and last week, we worked with the FAOSTAT. So from here, we are going to click on Explore Data, and it is going to take you to the main data repository interface of FAOSTAT. And because we were interested in undernourishment, we were dealing with food security and nutrition, and we were dealing with the suite of food security indicators. And when we click on this, and this is just another data interface, just like World Development Indicators or UN Human Development Index. And the first thing we did here was we were going to produce summary statistics or descriptive statistics out of country data. So we selected all of the countries. We selected values for those countries. And first, we were interested in working with our dependent variable, in which case it was prevalence of undernourishment. And the prevalence of undernourishment, we were looking at not 2022 figures, but the year before, because it contains more complete data, as you will. And we were interested in getting the table output format, the CSV file, no 1,000 separators. And we were interested in none of these flags, notes, codes, units, and null values. And we basically downloaded this data and pulled data live from here. And then we would go to Excel, and we would basically open up a blank page. And from here, we would go to data. Again, by now, you know how to do this very well, depending on whether you're using a PC or a Mac or a newer Excel or an older Excel. We're essentially interested in importing text data because comma-separated values, or CSVs, are essentially text data, which needs to be parsed into Excel format. And from here on out, we were interested in getting FAOSTAT, essentially the latest data that we downloaded from here. And this wizard was the CSV text import wizard, or text to column wizard. We used this many times before. This is a delimited file because the delimiters are commas, these are separators. This is not a tab separated file, this is a comma separated file. And because this is a comma separated file, we were interested in designating separators so that it doesn't parse the data in a wrong format. Our decimal separators are dots, and thousand separators are nothing, the third choice. And we were basically parsing this into existing sheet at A1 cell. So this is practically the data in parsed format. Now let's make this bigger so that you can see it better on your screens as well. What we're interested in doing here is that we are going to do summary statistics or descriptive statistics. And in doing so, first thing I need to do is that I want to clean this data. So this is suite of food security indicators. I already know that. And the data is prevalence of undernourishment %. Basically, what percentage of that country was undernourished in terms of the minimum caloric intake designated by the FAO for that given year. So before even working on this, I notice here that for Afghanistan, between the 2-year interval 2020-2022, the prevalence of undernourishment was 30%. Almost a third of Afghanistan is undernourished, which is an extremely high value. So here, what I'm interested in doing is that I am going to clean this and get rid of some columns. But if, for example, you're working with multiple pages of data in the future, you need to understand what this data shows essentially. So it is important to copy and paste these things somewhere you can see in the data set, so that further along you understand what this data contains. So domain, food security indicators, item, prevalence of undernourishment, 3-year average. So now that I have these at hand, I can start cleaning this. And perhaps it is a good idea to also rename the sheet. The sheet name doesn't really take too many characters, so we need to be economical. Undernourish 2022. So when you're working with, for example, let's say 40 or 50 pages of data, you need to know which page contains what data right by looking at the name. So now I can get rid of column A, I can get rid of the element value, I can get rid of item prevalence and whatnot. And also I have to copy and paste this year designation as well, so that after deleting this and cleaning this, I still have a designation of what this dataset contains. Now, what I'm interested in doing is that I want to convert this into a table. So from home, I'm going to convert this into a table. Make sure that the first rows are kind of special sortable formats like these, like these, like these. So I'm converting this into column format. You can pick any one you like. What is the data for your table? Well, the data for my table is beginning with area and value. I go all the way down to the data set, all the way down to Zimbabwe. So columns A and B, row from 1 to 2,205. And notice that this table has headers because the area designator and the value designator are there. So it's important to tick that option so that Excel doesn't treat those as string values or numerical values. When I click OK, your selection overlaps with external data ranges. Okay, no problem. So now we have this converted into a table format. And for my first exercise, I'm interested in first sorting these from in a descending fashion from the highest to lowest. And by now, you're going to see that although Madagascar and Central African Republic have the highest values, because we have this smaller than operator, it basically ranks them at the top. Now, it is up to us how to deal with those. So according to FAO, any country where undernourishment prevalence is below 2.5%, which means that less than 2.5% of the population is undernourished, they don't really take them specifically into the data set. And you're going to notice that this data set contains wealthy or upper middle income countries like Australia, like Austria, like Czechia, Denmark, France. So these are not underdeveloped countries. So anything below 2.5% is ranked below 2.5% for FAO. So it's up to us what to do with those. So if we were doing some kind of categorical variable work, we could have worked with those, but I need specific numbers because I have to explain to you how to do descriptive statistics and summary statistics. So what I'm going to do with those is that because I do not have specific values and because I cannot go to every single one of those countries' statistics offices and take the actual numerical undernourishment values, for my purposes, I will get rid of those. So that because I'm going to work with summary statistics, the designation below 2.5% is not really useful for me. There are different versions of dealing with this. We can just, for the sake of training, call them 2.5, actual 2.5. We can do arithmetic average of 2.5 and 0 divided by 2, which is 1.25%, and then assign. But that's not good statistical practice, so it's best to just get rid of all of those countries. So we focus on these actual numbers. So we have to delete rows, and we have the actual ranking of countries by prevalence of undernourishment. You're going to notice that this data also contains missing values. This doesn't mean that countries do not have hunger. So in Bahrain, you have hunger. In Cook Islands, you have hunger. Missing data can happen for a variety of reasons. Maybe they're not collecting data. Maybe 2022, 2020 values are not available for that given year. So I can't work with missing data as well. So I also have to get rid of these missing values. I have to delete them by rows. And the sample I have now is 117 countries. The smallest is Chile and goes all the way up to Madagascar. So what we can do is, just like we do every single time in previous lectures, we can do some very basic visualizations out of it. So for example, we can produce a chart graph, bar graph. This gives you basically the prevalence of hunger. So not hunger, prevalence of undernourishment, 2020, 2022 figures by country. Of course, these are just available values. Notice we also had not available values. Maybe there were higher figures there, but since nobody measured for that year, we can't really know. So in order to make our data screen tidy, let's bring this here. You can choose any graphical options you want. You can change the colors if you want. If this is not a meaningful graph, you can always go and using the data selector option, you can always pick, for example, top 50 countries by undernourishment. This makes this rather more legible or meaningful from that point of view. So this is one graph you can prepare. Then we can select all the graphs as all the data again. We can look at different options here. We can create, for example, a tree map or a hierarchy graph, just like we did in class. So let's put this here as well. Let's see what this is. Not a very legible graph. So what I'm interested in is this style 7. It could be different in your own computer, but I don't need this legend here because the country names are all already written on the little boxes. So I'm picking this. This is also not very helpful. There are so many different countries. So maybe I should, again, pick data, top 50 countries by level of hunger, level of undernourishment. So this is hierarchy graph of top 50 countries by undernourished. Again, you can pick any graphical options you want. You can change the color codes. You can rank them by color if you want. If you want kind of like a similar graphical principle as the one at the top. This is just intended to remind you before midterm, we were working on these visualizations. Now, what I'm interested in doing is that rather than picking nice visualizations, I'm interested in actually doing some statistical measures out of it. So for those of you who don't have this data analysis option here, in the data analysis tools, you need the analysis tool pack downloaded. So if it's not downloaded, please download analysis tool pack. Because when you click on this data analysis option, it should appear here. We're interested in descriptive statistics. Now we're interested in the general tendency of this graph. I'm interested in general distribution of this graph. So the way we do this is by clicking on descriptive statistics. So this is the descriptive statistics wizard. The first input it asks me is range. Where is my data? So I'm not selecting the value here, not the header. I'm not also selecting countries. I'm purely selecting the numerical values. Beginning with B2, Madagascar 51, I'm scrolling all the way down to the end of the data, B117. This is my range. Because I haven't selected the values, I'm not clicking labels in the first row. This data flows vertically, which means that it's grouped by columns. If this was flowing horizontally, this would be grouped by rows. I need summary statistics with 95% confidence interval. And I need the output range to be somewhere I can see right next to my data. So a comfortable window where you can just see right next to all of these graphics that we produced. Input range, just values. It's grouped by columns, no labels in the first row. If we selected value, we would have picked labels in the first row. Output range here, summary statistics. Okay. Now we have a summary statistics table. which basically explains to us the general tendency and distribution of our data. So again, this is not a sample that contains all of the world, because we got rid of developed and upper middle income countries whose undernourishment rates were below 2.5. So richer countries are not in the sample. And also missing value countries are not in the sample as well. So we only have, out of total number of countries in the world, only 117. So this is just a descriptive statistics of FAOSTAT undernourishment 2020. I mean, always as good practice, title your graphs, name your graphs, because after working with those a week later, you won't forget them. So, if you don't look at these things for a week, you will forget. If you're working for a company or if you're working for your professor, he's not going to understand what these are unless you name them. So what are these? So in the exam, it's going to be open book. So your book, your course notes is going to be with you. So when interpreting these results, you'll be able to look at your course notes. But of course, I am going to ask you to also interpret these values, because producing this graph is easy. Interpreting them is what makes a good data analyst. So the mean is 14.70. So how do we interpret this? On average, in our sample of 117 countries, 14.78% of the population is under nourished. Let's scroll further. So we have 117 countries in this list. So 14.78% of the population in those sample countries are undernourished. That is what the mean tells us. So a standard error in that context means that around 1.13% of margin of error exists in the estimate of the mean when the sample is used to infer the mean percentage of undernourishment of the wider population. So you basically have about 1.13% margin of error. So median at 9.7 means that half of the countries have an undernourishment percentage below and above 9.7. And half percentage is about this. Below now. So these are really, really high numbers. So when you think in terms of what we were discussing in class, how bad is undernourishment in terms of how bad of a global problem or crisis is this? It's a big crisis. So in our sample, about 15% of the population is undernourished. This is a very high value. And about half of the countries exist below 4.7% median, but then half of them is also above that. So it's highly problematic. In this data, mode is the most commonly occurring value. So in our data set, 4.8% undernourishment rate is the most commonly or most frequently appearing actual number. And the standard deviation in that sense is 12.2. It's quite high. There is a wide variation in the undernourishment percentages across sampled countries with an SD of approximately 12.2%. So what does that mean? This means that values are spread out from the mean. It means that the variance of undernourishment is quite large. Some countries are really, really, really hungry, and some countries are less so. And sample variance is 150. It's quite a large value as well. This is a measure of the variance within the data set, and with a high value, it suggests there is significant variability in undernourishment percentages. If, for example, we had more countries clustered around kind of the mean, around 14%, this would be kind of less, but we have quite a wide variance of the distribution of hunger. Now, in terms of kurtosis and skewness, so we are dealing with 0.75. So the distribution is not actually, it's above, it's below 3. So the distribution has a very low tendency to have outliers or extreme values. This is happening because we got rid of the rich countries in the list. So if we knew, if the FAO knew the actual undernourishment percentages of rich countries, this would be higher kurtosis value in which it would be very widely distributed, because we already have some kind of selection bias here, because we got rid of missing values, rich countries, due to data unavailability. So we automatically rendered this kind of not too peaky, kind of about outside. So the kurtosis value shows you how pointy, if you will, or how flat the distribution of your data is. And in this context, it is not very pointy. So not very pointy, the curve. So how do you know what to write? So you have 3 readings uploaded on our LMS interface. That basically explains to you what these values are. So what you have to do is that you can use cheat sheets that I provided to you. You can do the readings and actually learn how to interpret those. So it's in your readings, and your readings are going to be with you in the exam as well. So it's open book. You can just look and interpret these results in real time. Do not forget to save your work. Always save your work. So you can say IR202-FAOSTAT week 11, something like that. Skewness was about how right-leaning or left-leaning your data is when the data is clustered, whether it is clustered around lower values or higher values, or right in the middle of your data set. And this is a positively skewed value. This is a positively skewed data in which mean is greater than the median. So there are a few countries that are pulling this towards the right, in which their undernourishment is quite higher. The data is pulled towards the data pulls the mean to the right. When we're doing a histogram, you're going to see what this actually is. The range is the distance between the lower value and the higher value. And the range, you can see the lowest value here is Chile, and the highest value is Madagascar. So this range is basically the difference between Madagascar highest value and Chile lowest value. The minimum value is 2.5. Chile, the maximum value is Madagascar, the highest value. Some we don't really use because these are percentages. There's no point in summarizing percentages. But we have 116. Of course, I counted wrong initially. I said 117, but the first row is actually the header row. So total number of countries in the sample. So this is essentially how you do descriptive statistics. I always like to just color them. Because I want them to look interesting and kind of exciting. So you can basically use these to color. So this is essentially how you do summary statistics in that context. Maybe we can then add a histogram. I can once again select these countries. So histogram, remember, was about getting a sense of the general tendency of the data. Is it clustered among lower values? Is it clustered among higher values or in the middle? Or how much clustered or how distributed your data is? So we go to inserts. This was the histogram analysis, the statistical analysis. This was our histogram. So by looking at this, I understand that it is clustered among lower values. There are a lot of countries, about 60 countries, that lie in between 2.5% and 11.3%. 27 countries that exist in between 11.3% undernourishment and 20.1% undernourishment, and so on. And this basically explains both kurtosis and skewness. It is skewed so much towards the left-hand side that it distributes towards the right. And the kurtosis is, so we can basically play with this by formatting data series and get a more detailed view, for example, of this histogram. In class, we noticed that in PCs, bin controls are somewhere else. I'm using a Mac. This is not a very new Excel. In newer Excels, it's slightly in a different place. But we basically have to format data series, and then we have to go and find the bin controls. Bins are these boxes in which country numbers are clustered. So I need the number of bins to increase. This only contains 6 bins, so I need more detail to this clustering. So I'm basically increasing the number of countries in this data. So to make it maybe meaningful, maybe intervals of 5%. So most countries are clustered in between 2.5% hunger and 7.35% hunger. And then how bad undernourishment gets across countries is rather flat. So you can, in the quick layout, let's see, it also gives you the number of countries, add chart elements. Let's see if we can do not a grid line, but a trend line. Let me look here. Format data series. Let's look number of bins. So in order to add a trend line, we need to use the histogram here. But again, you can actually see this quite easily visually. We don't really need a trend line on this in order to be able to see how the data is clustered. So let's move this here. And let's name this histogram of undernourishment by country, 20 average. More number of countries have lower levels of undernourishment, and countries that have problematic levels of undernourishment gets kind of increasingly low. So you have this kind of declining curve across countries. So when you're, for example, working for FAO, or when you're working with an international institution like IMF or World Bank, or any international aid organization like the International Red Crescent, International Red Cross, these are very important statistics to plan where to send food aid and how to prioritize your long-term aid distribution strategy. So this is basically just a recap of these things. Now, I'm also interested in doing a correlation analysis. Why are countries hungry? In IR202, I'm not getting into regression analysis. I do this in my 300 code courses. So IR202 ends in correlation. I'm going to show you how to do a correlation table. But in order to look at actual causal mechanisms and answer questions such as, why are countries hungry? You need to do more causal analysis, and regression analysis is just one of those. So let's open up a new sheet. Let's rename this undernourish correlation 2022. So you have to be economical in terms of how you name these sheets. You can't really write very long information here. It doesn't allow you to do so. So it's very important to be as economical as possible. Let's save our work always. So we need to go back to FAO, and we have to, let's refresh this so that we can pull data again from scratch. So now, instead of countries, I want special groups of countries. Countries grouped together based on indicators. So what are the kind of indicators that we can think of? So there are different ways United Nations categorizes, poor, underdeveloped countries. And one of those is least developed countries, or LDCs. So you can basically ask Google, what are the least developed countries? The UN has a list of least developed countries, or LDCs. And it basically gives you specific designators, more indicators of why these are LDCs. Why are these designed as LDCs? So it gives you two options: LDCs total, LDCs list. The list gives you the actual list of countries, but I'm interested in doing a correlation analysis with multiple indicators. So I want their averages. So all of the average amount of undernourishment LDCs have. So I need total. Landlocked developing countries, small island developing, low-income food deficit countries. So what are low-income food deficit countries? So FAO has a list of LIFDCs. So there are 44 countries that basically, and the classification rationale is written specifically. There is basically a specific code book that determines how countries get designated as low-income food deficit. So I need the totals of those as well. And low-income economies. So I also want low-income economies total. So least developed countries, low-income food deficit countries, and low-income economies. So which one of these designations are the most accurate when capturing the correlates of undernourishment? So that's what I'm trying to do right now. I'm picking value again. So from here, my dependent variable, of course, I'm not doing causal analysis, but before I do causal analysis, I first need to look at basic correlation to see, whether there is interesting correlations that I can later on pursue in causal analysis. So my intended this dependent variable is prevalence of undernourishment %. I'm not looking at number of people undernourished, millions, because undernourishment in, for example, Bahamas, which has a low population, of course, numerically, it's going to be less than a place like India or China, which has enormous population. So maybe, 1 million undernourished in Indian context is, of course, not good. But in terms of how problematic it is not the same thing as undernourishment of 1 million in Portugal, for example. So we need to have some perspective. So that's why we're looking at prevalence of undernourishment %. Now, I want some correlates that can serve as independent variables for this. So what indicators are meaningful in terms of correlating with prevalence of undernourishment? So I'm shopping for indicators. These are all different ways of choosing different levels of measuring undernourishment. So I'm basically looking at things that could logically make sense. So are countries that are poor in terms of gross domestic product per capita purchasing power parity, does it correlate with prevalence of undernourishment? Can we say that poorer countries in terms of GDP per capita purchasing power parity have a higher likelihood of correlating with undernourishment? So that is one of my correlates. Prevalence of undernourishment, it's the same variable that we picked. Prevalence of severe food insecurity in the total population. So cereal import dependency ratio. Cereals are, so let's see, cereal food types. So there are 10 types of cereals that you can easily get are wheat, rye, sorghum, rice, oats, maize, barley, millet, quinoa, and corn. So these are very what we call staple foods in any given culture, any given part of the world. These are the most easily attainable, easily produced, easily harvestable, very difficult to perish, very strong seed types. And if we are to fix undernourishment and hunger in countries, the first thing that we have to make sure is that these countries receive at least enough of these staple foods, the most easiest to preserve, easiest to harvest kind of staple foods, so that that serves as the basis of nourishment in those countries, so that we can then move upward from more diverse diets, fibers and proteins. But first, we have to look at how dependent are those countries in importing these 10 types of cereals: wheat, rye, sorghum, rice, oats, maize, barley, millet, quinoa, and corn. So cereal import dependency ratio for those 3 years is what we are after. And then % of arable land equipped for irrigation %. What portion of that country's land is suitable for agriculture, both in terms of soil quality, but also in terms of being equipped, meaning whether they have basic irrigation infrastructure. Do you have the infrastructure that can water that agricultural area? So FAO measures these things, and per country, they have a statistic called percent of arable, meaning ability to do agriculture, equipped for irrigation, whether it has watering infrastructure. Sometimes based on global warming, low rainfall, destruction of irrigation infrastructure, for example, when you have countries that are undergoing civil war, conflict, terrorism, or actual war, the irrigation equipment can get destroyed. Or if the irrigation equipment is very old, they may become obsolete or they may break down, which is why the percentage of arable land equipped for irrigation changes by year. So we also need this variable. I would expect countries who suffer from a lot of political instability and violence and terrorism to have high levels of undernourishment. Because when there's political instability, violence, and terrorism, agriculture suffers greatly. Agricultural machinery gets destroyed. Farmers get killed. Farmers have to flee arable lands in order to save themselves from violence. So there can be migration away from those areas. So political stability and absence of violence and terrorism, I would assume, would be negatively correlated with hunger, which means that if political instability, violence, and terrorism increase, I would expect undernourishment to also increase. So how many variables do I have? Cereal import dependency ratio, gross domestic product, percent of arable land, political stability. 1, 2, 3, 4, 5. 5 is good. So because I'm going to go do a correlation analysis, I need longitudinal data, which means that my data has to have a time span so that I can look at whether increases in one variable correlates with the increases or decreases in some other variable. In order to do a robust correlation analysis, I need as long-term data as I can. So I need all of those years, beginning with 2000, which is the interval, 2-year interval between 1999 and 2001. And it goes in this fashion. Again, I need these as table. I need these as CSV. I don't want any thousand separators. I do not want any output formatting options at all. Then I download this data. Here, I go to my blank new correlation page. I go to data, and I am importing my latest data as well, the CSV, the latest I downloaded. I am going to parse this just like we do always. The regular settings, finish, and paste them. Okay. Now we have successfully managed to parse this CSV file. Once again, I'm going to clean this. And while I'm cleaning this, I'm interested in, or maybe, let's see, should I clean these? Let me clean these. And I am going to select domain, suite of food security indicators. I'm copying them. I need area. I can get rid of element value, but because these are, of course, value designations, I don't need to copy them. Actually, let's convert this into a pivot table. Let's not, sorry. data. Let's only get rid of suite of food security indicators because I already know where they're coming from. And I am going to do a correlation analysis from this, but this data is a mess right now. In order to do a correlation table, I need these years and indicators right next to each other. So I need years here, and then values of GDP here, for example, and prevalence of undernourishment here, political stability values here, and other indicators that I picked right next to each other so that I can select these all together and then do some kind of correlation by year, whether increases or decreases in one variable correlate with increases and decreases in some other. So the formatting of this is a mess. I cannot do any kind of anything from here. Maybe I can just get rid of the element as well. These are all values anyway. So I need to convert these in such a way that the values based on least developed countries, low-income food deficit countries, and low-income economies are all clustered right next to each other. But again, I cannot type them manually in a horizontal format, which is why we use a thing called pivot table. So normally, on my computer, summarize with pivot table option is here. But if you're using PC, if you're using an older Excel, you can go to help. You can just type pivot, and it is going to show you where pivot table controls are. So when you go help, when you go to pivot, when you type pivot, and it gives you a menu of items, when you say summarize with pivot table, it shows you where that option is. So what I'm going to do is that I'm going to use pivot table to structure and format this data in such a way that it is ready for correlation analysis. So I go to data, I go summarize with pivot table. Now, this is pivot table interface. Select a table or a range. We use this selector button to select everything. I need all of the values. So row 316 until column D, I'm selecting everything. I can actually, of course, let's create a new worksheet for this to be pasted. So create a new work sheet. So right now we are on sheet 3. Let's move it this way and let's rename this as undernourished pivots. Being tidy and kind of transparent and explainable in terms of the data work that you're doing is very important. So file management, file naming, folder management, these are all very important tasks for all of you. So it is important to be as tidy as possible. So here in the pivot table, it gives me 4 options: area, item, year, value. So first, I'm going to just select them and see what happens when I select all of those. So it distributed row labels as my indicators: serial import dependency, GDP, percent of arable land, whatever. Count of area, so how many countries exist in each indicator. You're going to notice that some variables have missing data in those. So for example, prevalence of undernourishment has 69 area designations in it. But for example, in terms of count of area, count of year, they are quite different. So these are just distributed in such a way that is not very conducive to what I'm trying to do. So I am dragging and dropping count of year because I want them to be listed horizontally across columns. So I'm carrying years into columns. So now it's basically spread my data out in a horizontal fashion. But again, it's not what I want. So values here have to go into the values column. This is where it belongs. Oops, sorry. Oh, so it doesn't allow me to do that. So I'm picking count of area and putting in the rows because I want all of my region groupings to be listed vertically. So I'm picking them here. So I have started to make this as meaningful as possible. So it says serial import dependency ratio, gross domestic product. That's not how I want it. I want basically area to be at the top so that rows are reorganized, not based on item, but based on area. So I put area top, I put item at the bottom. So least developed countries, low-income economies, and low-income food deficit countries are all sorted separately. And I have the same number of variables or indicators that are identical, basically. Values should contain sum of all values. Year should contain years, area, item. Okay, so now I have a problem. You're going to notice that some of the indicators that I have, such as GDP and such as prevalence of undernourishment annual value, these are listed as single year. So 2000, 2001, 2005, whatever. But some of my other or majority of my indicators are 3-year averages. So they contain year designations 2000, 2002, 2001, 2003. So they contain year ranges. So I have to merge them. And the only way I can merge them is to take what is in the majority, so 3-year averages, keep them, and then what is in the minority, so GDP and prevalence of undernourishment, copy and paste them under the interval range, so that at least I have continuous set of data to produce an actual and accurate correlation table. So in pivot tables, I cannot copy paste. So for example, if I choose these values and I go copy, and then I try to paste, you're going to notice that it's not going to allow me to paste. If I try to paste it manually, it says we can't make this change because it will affect the pivot table. You cannot alter a pivot table. So what we have to do is that we have to copy the pivot table and paste its values as values in the bottom to be able to manipulate and change them. So we have to select these all, the entire table, we go copy. And then underneath, in fresh new place, we are going to be pasting them as special values. Now, paste special values means that you are going to take these, the values, the contents, the numerical values of those, and then paste them underneath somewhere so that it becomes modifiable or manipulable. So copy the pivot table, not paste it as it is. If you paste it as it is, it's going to also paste the parameters of the pivot table. We don't want that. We just want the values. So the values have to go at the bottom. So what I'm interested right now in doing is that in order to not to mix these, so row labels, so let's make these color coded and bold so that they don't mix up with the rest of the data that I'm trying to work with. And the totals don't mix up. So gross domestic product per capita, 2000 figures all the way to 2021. I am copying them and beginning with 2000, 2002 values, I am pasting them in such a way that they converge with the rest of the data. Then I do the same thing for prevalence of undernourishment. That now I'm holding the control button, and in Max, this is the command button. I'm selecting multiple rows. Make sure that the number of rows that you're selecting are the actual same number of rows. So that hopefully when I copy this and paste them here, oh, it didn't do that. But anyway, okay. So I have to do them manually. So I'm going to take the first row, paste it here. I'm going to take the second row. You can also cut and copy because we're going to delete them anyway. So what you can do is that you can go, instead of copy, you can do cut, and then you can paste. I'm just doing it with my computer. So the cut shortcut on PC should be Control X. On Macs, it should be Command X. Or you can do that with just the mouse as well. Okay, so now I have a continuous set of data that I am working with, which means that I can just get rid of these empty values that contain only years. And then delete. So it's going to say, if you're going to delete this, what do you want to do? Do you want to shift cells up, shift cells left? We have to take this 2000, 2002 figures and then push it all the way down to B28 column. So shift cells left. Now I have well-functioning, normal-looking data that is prepared and formatted for correlation analysis. Now, there are missing values, of course, but it will not prevent us from conducting a correlation analysis. Now, how do we do correlation analysis? We go to data, we go to data analysis, we go to correlation. The first thing, I'm going to prepare 3 different correlation tables. So for least developed countries, a different one. For low-income economies, a different one. And low-income food deficit countries, a different one. So I'm going to go and do input range. So the first correlation I have to make is prevalence of undernourishment, percent annual value, and 3-year average they basically flow in a similar fashion. So I don't really have to pick both. So what I can do is that I can just choose these values, and then I can. So these are not grouped by columns anymore. These are grouped by rows. So they are flowing horizontally. We don't have labels in the first column. And then the output range should be right next to them so that we prepare a tidy visualization right next to it. And then we click OK, and it gives us a correlation table of these rows. Now, let's do the same thing for low-income economies. The range we have is here. Again, I'm not picking prevalence of undernourishment percent annual value, because the 3-year average also already gives me the trend for those country groupings that I want. Because if I pick both, their correlation will be almost 99%. So there's no point in looking at the correlation of something that already we know is the same measure. These are grouped by rows. The output range here is again right next to the row to which it belongs. Okay, now we continue doing the same thing, correlation analysis for low-income food deficit countries. Yes, I'm not picking the grand total, I'm just looking at the years. The output should be here. Okay, so now I have 3 correlation tables that I can work with. Now, let's copy these indicators, because in order to see what is what, I need to copy these actual indicators numbers here so that we accurately see what is correlating with what. And the same thing goes for copying and pasting these column-wise as well. So this is wrong. Take it back. Oh, sorry, I made a mistake somewhere. So I'm taking these. Okay. What is going on? Okay. So serial import dependency ratio, serial, okay. GDP, we copy it. This is at row 2. Percent of arable land. And prevalence of undernourishment. Next. Maybe we can just write some variable indicator code names. These are too long. So let's, for example, call it serial imports. That gross domestic product, GDP per capita. So GDP, PC, purchasing power parity, arable lands. Also not arable, but also arable irrigation lands. Prevalence of undernourishments. Percent undernourished. I'm basically converting them into code names so that the correlation table doesn't look strange, so that it is more meaningful when I try to interpret the results. So serial import dependency goes here. GDP per capita goes here. Let's make these smaller as well. Arable irrigation land goes here. Percent undernourished also goes here. Okay, so and then copy them, paste them here, and paste them here. Good. So finally, so these are least developed countries. These are low-income economies. And these are low-income food deficits countries. Good. So let's look at the results. So serial import dependency and GDP per capita, they're not really correlated. So it is, you can write something along the lines that at positive correlation, serial import dependency is not correlated with GDP per capita purchasing power parity of LDCs. So it's not really something that I can work with. But arable irrigation, so what was this? This is percent of arable land equal for irrigation. Now that is very correlated with serial import dependency. So we can say that LDCs that have basically, wait, is this, so this actually positive correlation. So that is very interesting. So percent of arable land equipped for irrigation. So as this increases, that's so interesting. Cereal import dependency ratio also increases. I would have expected the actual opposite. I'm looking at the data and it's positive. That's very interesting. I would have expected this to be completely opposite. So I'm a little bit shocked. So in the next analysis, in regression, which in IR202, I'm not going to teach you, but for example, if you were taking an actual statistics class and learn more causal analysis, this would be something worth exploring. Why is this happening? Why are countries that have a lot of arable irrigated lands are cereal import dependent? That is extremely unexpected. So LDCs that have, or the more arable irrigated lands LDCs have, the more they tend to become cereal import dependent. And the correlation is very strong correlation. Now, it's not the same kind of strong relationship between the availability of arable irrigated land and GDP per capita. So we can continue by saying it's not, but LDCs on average have weak correlation between GDP and arable irrigated lands. This is quite unexpected, not the relationship between arable and GDP, but this is super interesting in such a way that this is a very strong correlation. Now, percent undernourished, so cereal import dependency is highly correlated with percentage of undernourishment. So LDCs that are highly cereal import dependent tend to have great undernourishment percentage of population. Correlation very strong. But there is no relationship between, again, GDP and percent undernourished. So we can safely say that it is not really wealth that is making countries undernourished. So, however, wealth of LDCs on average is not correlated with undernourishment. But availability of arable irrigated land is highly correlated with undernourishment, which is quite interesting. This actually forces me to go back to the code book and look whether this is measured negatively. But no, I mean, it's very clear. Prevalence of undernourishment, percent of arable land equipped for irrigation, cereal. No, these are all positively coded. So I'm highly surprised with these results. So when I look at the correlation analysis, I kind of shop for items that I would go and work on a little bit more. But I can slightly say that the kind of relationship that we explore or identify in least developed countries cannot be seen in low-income economies, which means that yes, poor country designation is very different across economies. So the relationship between GDP per capita and cereal import dependency for low-income economies is, of course, it's negative and it's very insignificant. But the relationship is gone in cereal import-dependent countries and arable irrigated land. But on the other hand, GDP per capita and arable irrigated land are very highly correlated in low-income economies, which is quite interesting once again. Whereas percent undernourishment and GDP per capita is slightly moderately correlated, but it's inverse. So if a country's GDP increases in low-income economies, percent undernourishment declines, which is very expected that way. So let's, on the other hand, percent undernourishment and arable irrigated land, these are also moderately negatively correlated. It means that if a country has more arable irrigated land, less undernourishment it tends to have. So this is more meaningful compared to the other one. So in the next phase of a study like this, it would be meaningful to actually look at country groupings, which countries are listed in those, and do a country level analysis rather than country group level analysis. Here, GDP per capita among low-income food deficit countries, this is quite high correlation as well. This is moderately high. This is also quite high. This is negatively quite correlated. This is moderately negatively correlated. So here, I could say that for low-income economies, there is no strong correlation between cereal imports dependency and GDP per capita purchasing power parity. Also weak, not weak, but this is actually minus 0.5. It's moderate. So moderate inverse correlation between availability of arable irrigated lands and cereal imports dependency. So let's write it more meaningfully. Moderate correlation in terms of as a low-income economy, arable land percentage increases, its imports, cereal imports dependency declines. And its GDP per capita tends to increase. So it's positively correlated. Low correlation between cereal imports dependency and prevalence of undernourishment. But as a low-income economy GDP per capita increases, its undernourishment percentage decreases, which is quite predictable. Also, as a low-income economy, arable irrigated land increases, its undernourishment percentage decreases. So there's inverse correlation. Now, finally, for low-income food deficit countries, as GDP per capita increases, cereal import dependency increases strongly as well. Whereas moderate positive correlation between cereal import dependency and arable irrigated land, which is also quite interesting. You know, I would expect the more a country's arable and irrigated land increases, the less cereal import dependent that country would be. So this suggests that there are some problems, infrastructure problems or labor problems or arable land exploitation problems or impediments that actually prevent a country to take actual full benefit of its agricultural land. So there's a moderate positive correlation between cereal import dependency. That's quite interesting. Also, low-income food deficit country GDP per capita increases are strongly correlated with their arable irrigated lands, which is, again, these are quite surprising correlations, which merit causal relationship later on. Finally, to wrap this up, LFDCs have a moderate negative correlation between percent undernourishment and cereal import dependency, which means that the more they are cereal import dependent, the less undernourished they tend to become, which is very surprising. But richer they are, less undernourished they tend to get, which means that they are very import dependent. And the more arable land they have, the less undernourishment they have. Finally, more arable irrigated land they have, less undernourished they tend to get. Good. So basically, this is the kind of exercise that we're going to be doing in the exam. So today, what did you learn? You learned how to pull CSV data from FAOSTAT, parse it, clean it, produce some basic visualizations, produce descriptive statistics, produce some graphs, interpret descriptive statistics for a limited sample, then parse longitudinal data for country groupings using multiple indicators and variables. You learned how to use pivot table to format a raw data into a format that is suitable for correlation analysis. Then you learned how to do correlation analysis and learned how to interpret them. Again, if you need help with these interpretation texts, they're in your readings. I assigned to you some very good articles that show you how to interpret descriptive statistics, summary statistics, how to interpret correlations, and how to read variables and indicators in such a way that they make sense from a correlation point of view. Good. So that was it for today. Hopefully this is going to be more helpful for you. Don't forget to save your work always. Hopefully this is going to be helpful for you when preparing for your final exam. This is part 1 of this week's lecture. In the part 2, I'm going to show you how to work with SIPRI data, Stockholm Institute of Peace. Sorry, I forgot the full name of SIPRI. Stockholm International Peace Research Institute. We will be working with this military expenditure data set and how to do all of these things with a different data set. So cool. Let me know if you have any questions. Don't forget that we have 2 teaching assistants in this class, and they are waiting for your emails or waiting for your office visits. If you have any questions with any of those, you can ask me, you can ask our teaching assistants. We are here all waiting to help you, so please use us. Okay, thank you very much. Take care, and I'll see you on Thursday. Cheers.